So let's reduce these down. That was inadvertent.
What did you do with
This one? No, one to the right.
I thought we were just one.
This right here. It's this number plus this number, depending on age of the tip, whatever your year.
Oh, times the year.
Yeah.
Use this.
We want to reduce these decimal places. Now, what this shows is that the trend over the projected period is to reduce investment share very slowly down to 20.6. So the investment share started in 1990 at a very high rate of 32, but there's been a steady decline in this country of the investment share all the way down to about 20.6. But that is not bad, 20.6. Do you know what the investment share in the United States is right now? 13.4. If the United States could get its investment share up to 20.6, we wouldn't be talking about any unemployment. So this might be a good scenario. This might be one scenario for this country. The scenario is, in this country, that its investment share is on a declining trend, and over the next 10 years, it should go down to about 20.6, which is a reasonably good investment share for any country. Right? So we're going to use that scenario. So now what I'm going to do is say, okay, that's a fine. This is our assumption. Cross out projection. We're going to copy this. We're going to go back to sheet 2. We're going to go over here. Paste this set of projection. What happened to the other one? Let me go back to the other one.
Is that right?
This one, this one.
Yeah, well, it does go from
Copy. Go back to sheet 2.
First sheet, or is that just on the second sheet?
So that gives us our investment share.
Okay. It's making me very nervous.
253, 251, 238. Yeah, 238, we need to check. We had
That's
255, 253, 251, 2, 4, 2,
No, he just changed the change.
all the way down to 12.
Yeah, mine looks really good.
So, we're making a projection of this country's GDP using the Pyro-Domar model. But we have to make some assumptions. And this is our assumption. And that assumption is that the investment shares will continue to decline along this trend as they started, that we fitted with the regression coefficient. Now, let's go back to our model. I said this is our I-core. Now, for this Harald-Domar model, we have delta y is equal to b times I. Because y, remember y was equal to y t plus 1 is equal to a plus b times the sum up to t of I. Therefore, y t equal a plus b, the sum up to t minus 1 of y. Delta y, these two cross out, will equal to b times I of t. When you get that. Now, if we divide both sides of this by y, like that, this is our I over y, our investment share, equal to b delta y. This is our growth rate. So we can call this the growth rate of y is equal to b I over y. Another way of saying this, I over y is equal to 1 over b times the growth rate of y. But 1 over b is the I-core. I over y is equal to the I-core times the growth rate of y. Or another way of putting it is the growth rate of y is equal to I over y divided by the I-core. Right? So we can get now the growth rate of y simply by taking I over y, which we just computed in that column where we have double sum over both y, and dividing by the I-core. And that'll give us the growth rate of y. Okay. Now, to get the next y then, yt plus 1 will be equal to y at t times 1 plus the growth rate of y. Let's first compute these growth rates of y, see what they turn out to be. I'm going to take all of this stuff here and move it somewhere else. I'm going to take it, copy it, and we'll put it over here on this sheet over here.
That's why
We have it over here. If you want to keep track of these regression equations. I'll go over here and delete all of this. So that has to be. The I-core is
okay.
10.92195.
Oh, do you want to send me? Yeah, I do.
That's all right.
The I-core is what? Oh, that's right, yeah. I think so. That's what you said. What? Yeah.
I guess it's going to be the midterms. Well, you got 20 feet.
Right back. Thank you.
Or y, growth rate of y, is equal to this number divided by the I-core, and that's going to be 10.92.
Where's the I-core? It's not here. You moved it, remember? Oh.
195. So in 1990, the growth rate was 2.95%, almost 3%.
So we can drag that down.
So it's.
So what we have is a decreasing growth rate going down to 1.8%, 1.9%.
Divided by the
All right.
I-core, that's it.
All right. Now, to get the y, the projected y, that's going to be equal to the old y, which is over here, times, open parentheses, 1 plus the growth rate. The growth rate is given over here. All right. Everybody see that?
Where's the growth rate at?
The last column we just did.
Oh.
All right? Everybody see what I'm doing?
Yes.
Now you hit Control Shift Enter.
It didn't work.
And drag it in.
We need the I over Y.
What the hell?
We need the growth
And now we have projected y into the future. But as we project y into the future, each year its growth is slowing down, as it has in the past. It's using a slower and slower growth rate. But GDP is increasing, it's just that the growth rate is getting slower and slower, based upon this model.
If we can just figure out what to do with this.
Everybody with me? How many people are lost?
Just the rate of y, can we go?
We just, can you put the other spreadsheet up? Because the one with the,
Yeah, we want to raise it. All right, we're going to go through this carefully so you understand it. It's all basic macroeconomics. So this is what we start off with, right? These numbers. And our objective is to extend y into the future under some reasonable assumptions about what's going to happen in the future. All right? Good. Now what I did was I created, first of all, we might going to get a Harold-Domar reduction function. We need the sum of I and yt plus 1. The sum of y is gotten by you take the first I number, put it here. The second one is gotten by adding the second number here to the first one over here. And you drag that down, that accumulates the I. The next thing we need is yt plus 1. That's gotten by going over here, starting with the first year, 1991, not here, but here. Move that number up over here, and then they all follow. But you notice when we do that, this sequence is shorter than the original sequence because we removed the first number. We've got one number left. So now, with this pair, we estimated this regression equation that I have written up here. We estimated this. We got values of B there. Now let me show you where we did that. I moved it on to the other. Here's the Harold-Domar function. Yt plus 1 is equal to 5413.523 plus 0.091999 times the sum of I. This number comes from here, the intercept, and this number comes from here, the coefficient, slope coefficient. Is that all understood?
Yes. Yep. Yes, I get.
So now we have over here the coefficient of the Harold-Domar model, including the I-core, which the I-core is 1 over B. Now the next question was, how do we project into the future? In order to project into the future of the Harold-Domar, we need that I over Y. We have to have some reasonable assumption about I over Y. Now one way to look at it is to do what I over Y, instead of just computing I over Y, but to look at the cumulative effect of I over Y. How's that cum behaving? The reason why we look at the cum is because when you take investment, when you make an investment in the country, you don't get the return on investment necessarily the same year. It comes with a lag. But over time, as you keep adding new capital, new machinery, it begins to turn, it does its work. So what did we have to do? So what we did, we took the cum of the investment and the cum of the income to see what proportion was used over the long period. So that was the I over Y divided by, the sum of I over Y divided by Y. Here. That's this ratio here. And we saw that in the beginning of the period, the country was making great efforts, was investing about 32.3% of its GDP. Now when a country does that kind of thing, when it really makes that kind of investment, it grows fast, that high ratio of investment over GDP. What happens, however, is that it causes the people who, the investment class, to get rich, and the poor people to remain poor. over time. That's what happens. When you make this heavy, when you have very high I over Y, those people who are working in that modern sector, where the investment is going, they get rich, and meanwhile the peasants remain poor. Over time, what happens is that as the country begins to develop, you don't need such heavy investment up top. You can take some of that investment and channel it into government and start distributing that among the poor.
Just enough to keep them from riding.
This is a very typical pattern of any developing country. In the beginning, when they start growing, they take off very fast, but only a few people benefit from the growth. But after a while, as they mature, as long as they don't have a revolution, something like that, the country's starting to make money from the investment because the capital is accumulating. Then the country can cut back on the private investment and increase government investment, or government spending, and spend that money on the things that it needs for its citizens, like better education, better health benefits, and so on.
Is it synonymous to trickle-down economics?
Huh?
In any way, is it synonymous to trickle-down economics? Are there any similarities?
Well, trickle-down economics really is a kind of nasty term
Oh, okay.
for a market economy.
Okay.
But let's not use those kind of slogans.
All right.
I mean, there's a lot of them. When people use these words, they don't even know what they mean. But if you look at investment shares in developing countries, especially fast-growing developing countries, they're always high in the beginning. After they mature and they become more developed, that investment share goes down. When it gets down to about 20%, that's beginning to get realistic. In the developed countries, the investment shares are around 20%. The high-growing developing countries, developed countries, the fast-growing developed countries have investment shares around 20%. The aging countries like China and Korea, Taiwan, if you look at their investment shares right now, they're extraordinarily high, very high, in the 30s. But over time, they're going to have to lower those investment shares. And they're going to have to distribute more in terms of government consumption. Because if they don't, they'll have a revolution on it. The people at the bottom are not getting any benefit of the growth. Always the case. Now, in the United States, the investment share now is down to about 13.5% in the private sector. But we have the opposite problem. We've got to get the private sector to start reinvesting back in it. They're not doing it right now, and because they're not doing it, it's creating unemployment and a lot of problems in this country. So we're at too low investment share. China is at too high an investment share. Most countries fall somewhere in between the ranges. Korea went for many, many years with extraordinarily high investment share. And it paid off. Korea grew very fast. But the problem was, after a while, they had to absorb the people at the bottom who were not getting included in the modern economy. If they didn't do that, they'd have real problems. And that's what they're doing now.
Professor,
Yeah.
could you just go to the other page where you did the work for the projected?
Yeah. I'm just trying to explain why we did it.
Oh, okay. I got you.
To get these investment shares. So one of the things we want to do is project forward what this investment share might be in the future. All right? As reasonable. This is going to be a reasonable projection. It'll go down to about 20%. It's still high compared to the United States, but it would be just right for a Latin American country. Just the right place. So we took these shares over here, and we brought them over to the next page. here. We had it up to 2009. This is where we had it. Here's the share, black is 0.251, 2009. So these are the shares that we have. Up to here. And these are the years. And then we created a new column, which was the logarithm, but this was the logarithm base 10. I didn't realize I put that in when I did. The logarithm base 10 of 100 times this number. Now you might ask, why don't you multiply it by 100? If I didn't multiply it by 100, you would get all negative numbers. It wouldn't sound as good. But you could have done it. So multiply it by 100 and give it positive.
So should we actually use the base 10 log, or should we be using the natural log usually?
You can do natural log, or you can use 10 log, doesn't really matter.
So if I use
You just
natural,
gotta know what you use, otherwise you.
so if I use natural log, I have to raise it to the power, and if I use, otherwise I have to use that EXP. That's it.
If you use log 10, you don't use EXP function.
Okay,
You use 10.
10 to the power, okay,
10 is raised to whatever that thing is.
okay. Okay.
So now we got the this represents the regression here. Let me write it in. Let's see.
So it's this minus this minus that. This. Do that first. We gotta see what's there. I missed the spot 7, so I got this stuff. I gotta figure it out what the hell I missed.
Now this is only one possible scenario, that the investment shares don't change. I mean, they change gradually a little slower. Over the long. Over the years. That's the way we use our equation. So that's how we get these numbers from 2009 down. Over here, right here. See how I get those numbers? Putting that equation.
My coefficients. It's ridiculous. Got a series.
Sorry?
Is negative 0.07 time year?
Plus this.
Or
Yeah, 2010, whatever it is.
time
Times a year, right. You see the equation up there? You can see it up there in the thing.
Yeah.
We use the coefficient for that times 822.